So for today's video, we're going to go over some examples of factoring and prime factorization. We're going to start off with finding the factor sets of 3 different numbers, and then we'll move into finding the prime factorization of 3 different numbers. And so we'll start with factor sets. Now remember, factor sets are the entire group of factors that make a number. So we'll start with factor sets, so I'm going to go ahead and write factor sets. And we'll start with the number 30. Okay, so for the number 30, we need to find all the factors that make up this number. So I already know of 1. We have 1 and 30, obviously. 1 times 30 gets us to 30. Now, if we cut 30 in half, we get 15. So we know 2 times 15 also gets us to 30. Now, we can also look at 30 and say, okay, is it divisible by 3? It's not. It's divisible by 1, divisible by 2, and is it divisible by 3? Well, it is. 3 times 10 gets us to 30. And then, I'm about to run out of room here. But we also know that 30 is divisible by 5, and so we have the factors 5 and 6. So in total, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. We'll go ahead and move on to another number. We'll choose 48. Try and give myself a little bit more room here. And so for 48, we have obviously 1 and 48. If we cut 48 in half, if we say, well, is it divisible by 2, we get 24. Now, in doing these and finding factors, it is a little bit of trial and error. So let's say now, is 48 divisible by 3? Well, let's go ahead and divide it out. So if I take 48, divide it by 3, 3 goes into 4 once. I get 3 left over. Get 1 and 18. We see that we have 3. How many times does 3 go into 18? It goes in 6 times. And so I get 18, subtract that, and I get 0. So in this case, 48 is divisible by 3. And the remainder is 16, so that's another factor. Is it divisible by 5, though? Well, if we know a factoring trick, any number that ends in a 0 or a 5 is divisible by 5. 48 clearly does not end in a 5. Sorry, it does not end in a 0 or 5, so it's not divisible by 5. What about 6 now? If I try 6... how many times does 6 go into 48? Well, 6 goes into 4 0 times, so how many times does 6 go into 48? I know if I try 6 times 8, right, 6 times 7 is 42, so 6 times 8 is 48. And it goes in nicely, and I get 0. And so in this case, I have 6 and 8. Do I have anything else? Well, the only other number we have is 7, and 48 is not divisible by 7. So the factor set for 48 is 1, 2, 3, 6, 8, 16, 24, and 48. Now let's try another number. We'll try one more, and then we'll move on to prime factoring. We'll do the number 108. So this is going to have quite a set of factors. We already know 1 is 1 and 108. And I'm going to leave just a tad bit of room because I feel like I'm going to need it. 108 is an even number, so therefore it's divisible by 2. Which means we have 2, and what's half of 100 is 50, what's half of 8 is 4, so half of 108 is 54. Now, is 108 divisible by 3? Let's go ahead and find out. There is a trick for factoring, but well, seeing if it's divisible by 3, which is if the individual digits of 108 add up to 9, then it's divisible by 3. 1, 0, and 8 add up to 9. And so then it's divisible by 3. Actually, sorry, let me rephrase that. If the individual digits add up to a number that is divisible by 3, then the number that you're looking at is divisible by 3. So in that case, 9 is divisible by 3. But we'll go ahead and divide it out just to be sure. So 3 goes into 1 no times, so we'll move to 10. 3 goes into 10 3 times. We get 9. Subtract that out, we get 1, 18. 3 goes into 18 6 times. We get 18, and we get our nice lovely 0. And so then we have 3 and 36. Now, is it divisible by 4? It should be divisible by 4. So if I try and divide this by 4, get 108. How many times does 4 go into 1? It goes in no time. So how many times does 4 go into 10? It goes in twice. And I get 8. Check this out. I get 2. Bring down the 8. 4 goes into 28 7 times. And so then I get 28, remainder 0. Running out of room there, but that's 0 down there. So I have 4, and I have 27. I'm gonna erase these two numbers so that way I have a little bit more room. Let's go ahead and remove these. Sorry, these two problems that I did. There we go. Okay. Is it divisible by 5? Well, it doesn't end in a 0 or a 5, so it's not divisible by 5. Is it divisible by 6? More than likely, it's divisible by 6. In fact, there's a factoring trick that if the number is divisible by both 2 and 3, it's divisible by 6. So let's go ahead and work that out. So how many times does 6 go into 108? We get 6 goes into 1 no times, 6 goes into 10 once. We get 6. Subtract that out, we get 48. And obviously 48 now, we did that before. 6 goes into 48 8 times. So I'm just going to stop that there and I'm not going to continue the rest. So we have 6 and we have 18. Is there anything else? Let's see, can it go into 100? Can 108 be divisible by 7? Let's try that. So simply we just have to divide out. There's actually not a trick for dividing by 7, so you just have to divide it out. 7 goes into 1 0 times, 7 goes into 10 once. I'm left with 7. I'm left with 38. 38 goes in 5 times, but we end up... Gonna put that down there, but I'm gonna run out of room. But we're gonna be left with a remainder of 3, so that's not gonna work. So it's not divisible by 7. Next we'll try 8. Is it divisible by 8? Eight goes into 10 once. I'm left with 8, 28, and that is looking to be no. It's not divisible by 8 because the closest one is 3. 3 times 8 is 24, and I'm left with a remainder of 4. So it's not divisible by 8 either. Let's try 9 now. So I'm going to erase my division problems, but we're going to go ahead and try 9 next. Alright. How many times does 9 go into 108? Well, 9 goes into 10 once. I'm left with 9. So that is 1 is 8. 9 goes into 18 twice. And then I'm left with 0. So we have a factor set of 9 and 12. Well, that's good, because we're getting down to really only 2 numbers left. We have 10 and 11. Due to process of elimination, we started at the very end and we're working our way in. And so we already know the factor for 12 is 9. The corresponding factor for 12 is 9. So we're just left with 10 and 11. For 10, since this number, 108, does not end in a 0, it's not divisible by 10. So we don't even need to try that. What about 11, though? We can try 11. Chances are I don't think this is going to work. We can try it. 11 goes into 1 no times. 11 goes into 10 no times. How many times does 11 go into 108? Well, the closest one approximately is 11 times 10, which gets you to 110 if you can do the math quickly. So that means if we try one less, we would do 11 times 9, which would get us to 99. So obviously that's not going to work. So that means our factor set for 108 now is this giant group of numbers. Oh, that was a lot of fun. We have 1, 2, 3, 4, 6, 9, 12, 18, 27, and I'm missing a comma, 36, 54, and 108. Okay. As you can see, finding factors and finding the factor set of a number can be quite tedious. In a lot of cases, there are some simple tricks that I can show you after this, but for the most part, a lot of it is simply just working out problems. I'll show you tricks actually right now. Now is the best time. So let me go ahead and type something out. So basically, tips or tricks for factoring. All right. So tips and tricks for factoring. So a number is going to be divisible by 2 if it is even. So for example, 54 is divisible by 2 because it's even. 28 is divisible by 2 because it's even. 2 times 14 gets you to 28. So on and so forth. With the number 3, the tip for factoring here is you need to add... Actually, you know what? The better thing for me to do in this case is I'm actually going to just type out the results here for you guys, because I don't want to write it out by my hand. So in this case, this one needs to be even. And in this case, for free, basically you need to add up all the digits. If the added number is divisible by 3, then your number is divisible by 3. Okay, and so what do I mean by that? Let's take a good number, for example. Let's try 54. So we're going to find out if 54 is divisible by 3. Well, in order to use this little trick here, you need to add up the digits 5 and 4. And so we're going to get 5 plus 4 equals 9. And then we need to ask ourselves, is the number 9 now, is that divisible by 3? The answer is yes. 9 divided by 3 is clearly 3. So therefore, 54 is divisible by 3. All right. The next tip, there is a trick for 4, but to be honest, I don't remember it. I'm sure you could probably look it up on either Wikipedia or the internet. So I'm going to skip it for right now. Mainly in my experience with 4 is I tend to just divide it out. But for 5, if you want to look at tips or tricks for 5 now, the number must end in 0 or 5. So 5 is a factor if your number that you're working with ends in a 0 or 5. So 54 in our example is not divisible by 5 because it doesn't end in a 0 or 5. However, the number 70, 5 is a factor of the number 70 because it ends in a 0 or 5. Likewise is the same thing for 75, so on and so forth. Okay, now on to the number 6. So the hint for 6 is that the number must be divisible by 2 and 3. And I missed a letter. That should be a B. The number must be divisible by 2 and 3. So, put it quite simply, you use the factor rules that we found for 2 and 3. Whoops, that moved way too quick for me. So the number must be even, and then if you add up all the digits and that's divisible by 3, then you have 2 and 3, and then therefore you're also divisible by 6. It's actually really kind of cool. Neat little trick. If I recall correctly, since I'm doing this part off the top of my head, for the number 7, there is not really a trick for 7. Most of my professors have told me just to divide it out. Simply divide is actually probably the best thing. I heard that there was some sort of trick involving basically there's some weird number thing that you have to do that even I don't really understand. And it's actually easier if you just divide it out. And it'll actually just save you headaches. Similarly, for number 8, I tend to also divide it out, but I think there's a trick. I'm not entirely certain about this one. For number 8, I think if I remember right, it must be divisible by 2 and 4. And then it's divisible by 8. I think that's correct. Let me think about that really quick. 27, 54. If I use 54 as an example, no, that's not going to work. Yeah, never mind. Never mind, don't follow that direction. I'm going to go ahead and erase this, because we don't need it. I think the best thing for... Oh, can I not erase this? Oh, lovely. Excuse me for one moment. The best thing for number 8, then, is also following just 7, is simply divide. That's what I would tell you to do. So let me go ahead and type that out. I'm sure there is a trick for 8, I just don't remember it off the top of my head. And then for number 9, for the factor of 9, I don't remember that one either off the top of my head. I actually didn't plan to go over this, but I was going to give you guys just a helpful hint of tricks. I would say just to simply divide in this case. But I think there's something regarding that it must be divisible by 3. And I think also 6, but I'm not sure. No, that wouldn't work because 9. Yeah, I think there's something involving the number 3 here, but more than likely it's best just to divide. And then for number 10, the last one, this one is actually, I think, one of the simplest ones. All you have to do is just the number ends in 0. If the number ends in 0, then that means it's divisible by 10. So, for example, 10, 20, 30, 40, 50, 60, so on and so forth. If the number ends in 0, it's divisible by 10. I'm going to see if I can figure out the other ones for 7, 8, and 9, and I may post that in a separate video. In fact, I actually probably will post it in a separate video. That'll be something good. But for right now, we're going to move on to prime factorization. We'll finish out this video with some prime factoring examples, and we'll be done. So sorry, that was a little tangent into factoring tips, but now let's move on to prime factorization. Okay, so prime factorization, we're going to have 3 examples here, and we're going to start off with the number 36. And so there's multiple ways you can factor 36 or get its prime factorization. I'm just going to show you one of them, but if you want to work it out on your own, there's a few different ways you can do this. I'm going to note first that 36 is the multiplication of 6 and 6. I find that if I have 2 of the same numbers, it works nicely, because then I just have to find the factorization of one, and then I get the factorization of the other. So I know 6 in this case is also the multiplication of 2 and 3, and so therefore I get a 2 and a 3 on this side. And so then 36, since 2 and 3 are all prime numbers, the prime factorization of 36 is 2 times 2 times 3 times 3. And that's the prime factorization. Now we'll move on to the prime factorization of 60. We're going to move up a bit. So 60 in this case, in my experience, if the number is divisible by 10, I will use that first, because that tends to help out quite a bit. So if, in this case, 60 is multiplication of 6 times 10. I already know from just above that 6 is 2 times 3. And then 10 we know is 2 times 5. And so then, since all those are prime numbers, the prime factorization of 60 is 2 times 2 times 3 times 5. We're going to move on to one final number, which will be 120. And so again, I'm going to use my same trick. I note that 120 is divisible by 10, so I'm going to get 10 on one side, and the corresponding factor with 10 is 12, because 12 times 10 gets us to 120. Now, 10 I know is 2 times 5. We know that from above. And 12 in this case, I'm going to use 4 times 3. You could also choose 6 times 2 if you want to. In this case, I'm just going to choose 4 times 3. And then for 4, I know the factorization of 4 is 2 and 2. And at this moment, I now have all of my prime numbers. I have 2, 3, 2, and a 5. And so in this case, the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Now, one thing your teachers may know, and I haven't covered it here, and I don't know if I'm going to cover it, you can technically write the prime factorization as in terms of exponents. So as a little side tangent here, yet another side tangent, I could write 120 as 2 to the power of 3 times 3 times 5. Okay, because there's 3 2's here, and we know 2 to the power of 3 is equivalent to 2 times 2 times 2. So add that as a little bit extra. You get that as a bonus. But other than that, that is the end of this video.